Concurrency is key to develop highly scalable softwares, and parallelism is key to develop highly performing softwares. That is what I think about concurrency and parallelism. And in this video, my goal is to make you understand concurrency and parallelism as a layman. Before we begin, I request you to like and subscribe my videos in case you love them. Let's take an example of a gym where we have two runners and one treadmill. Both the runners enter the gym at the same time. Now, runner 1 and 2 both want to finish their workout in an hour, and no one wants to wait much for the treadmill. But the good thing here is, runner 1 says, I can run for 5 minutes and rest for next 5. And same way, runner 2 is ready to do the same. So how do we schedule a single treadmill for both of our runners so that they can use the gym efficiently without much waiting time? Let's solve this problem using concurrency. Here, the solution is really simple, and that is both the runners can share the treadmill. So one runner can run for 5 minutes and second runner can run for another 5 minutes while the first runner is resting. By using this treadmill sharing strategy, we are utilizing the treadmill to its full extent, and both the runners have treadmill when they need it. And this is exactly the way concurrency works. So now I will use some technical jargons here to explain concurrency. When we have one CPU and multiple threads to be executed on it, our operating system very intelligently schedules the threads that need CPU and threads that are going to some other stuff like file read, write, or network I/O, and not in the need of CPU goes in the wait state. So this is how concurrency works, and this principle is exactly the same for whatever programming language or platform you use. Let's now see what is parallelism. Let's go back to our treadmill example and change the condition that runners can wait for 5 minutes. Now our runners need to run continuously for 30 minutes. So in this case, one treadmill is useless because once a runner is over treadmill, another runner has to wait for 30 minutes to run over it. To solve this problem in the most efficient way, what we need here is another treadmill. And if we are able to get the second treadmill, then both of our runners will finish their run in 30 minutes without waiting. So this is how, using parallelism, we were able to achieve the maximum efficiency for our runners. Here, consider each runner as a thread and each treadmill as CPU. So to achieve maximum efficiency, we need two CPUs to accommodate two threads at once. In the examples I used, what we saw is using concurrency, we can accommodate multiple threads on a single CPU, and that gives us scale. And using parallelism, we can finish both of our threads at once, and that gives us efficiency. Operating systems use the concept of concurrency and parallelism together to provide best possible scheduling for our threads. The modern languages like Golang have taken this concept to the next level, where they have moved the concurrency handling within the language runtime. I'm going to create a video on this topic soon. So we should keep this video limited to the basics of concurrency and parallelism for a layman. So before finishing this video, I would like to say some key points. The key points that summarizes this video are as follows. With single CPU, you can only achieve concurrency. You need multiple CPUs to achieve parallelism. OS scheduler decide what to run and when to run. A badly written software can underperform even if you have multiple CPUs. You need concurrency to scale your software in a better way. The maximum degree of parallelism you can achieve is equal to the number of CPUs you have. So keeping the above points as key takeaways, let's finish this video and thank you and have a very good day.